Alright guys, on number 57 you're supposed to find the cosecant of theta, and what we have that looks like a degree mark but it's nothing. Just write that out. Okay, so what we have right here, when you think about this triangle, across from theta we have 15, which is opposite. We have beside it, which is adjacent, and then we do not have hypotenuse. What I would first do is determine whether or not you need the missing side, and if you don't, then you're good. Cosecant is the reciprocal of sine, and if sine of theta is opposite over hypotenuse, then cosecant is hypotenuse over opposite. So in fact, we do need the hypotenuse. I do know my answer is going to be divided by 15, but I got to figure out what the hypotenuse is, and we do that using the Pythagorean theorem. So the Pythagorean theorem says a squared plus b squared equals c squared. C is always the hypotenuse, so I've got 15 squared plus 5 squared equals c squared. Okay? Now, if I type those into my calculator, if I square them, I've got 225 plus 25 equals c squared. 225 plus 25 is 250. 250 equals c squared. And then I want to take the square root, so c equals the square root of 250. But you should always try and simplify. So when I think about what perfect square goes into 250, an obvious answer is 25. When I think about 250, 250 is 25 times 10. So if this is 25 times 10, then that would mean that this is 5 square roots of 10. Okay? So the hypotenuse is 5 square roots of 10. I'm going to put that over right here because my answer is hypotenuse over opposite. So 5 square roots of 10 over 15. What I need to do is make sure that I simplify. And when you look at 5 and 15 in the denominator, 5 divides by 5 once and 15 divides by 5 3 times. You can't divide the 10 by any of this because it's inside the square root, and you wouldn't anyway. So I've got square root of 10 over 3. And that's my answer. Okay, on the next problem, it asks for cotangent of theta. And again, I'm going to think about what I have. I have opposite, I have adjacent, and I do not have hypotenuse. But first I got to decide if I need it. Cotangent is the reciprocal of tangent, and tangent is opposite over adjacent. So that means cotangent is adjacent over opposite. So I just need adjacent over opposite, which I both have, or have both. So adjacent is 8, opposite is 19. 19 is prime, there's nothing that divides out, so we're good. Okay. On 59 it says use the given point on the terminal side of the angle theta to find the value of the trigonometric function indicated. What they're asking me is to make a triangle with that on the terminal side and then find the tangent of the theta, of the angle of the triangle. So first, I got to think about the point negative 5, 4. Negative 5 on the x means go left, and positive 4 means go up. So I'm going to draw a triangle in the second quadrant, going left 5 and up 4. Sorry. Okay. So, there's my theta. I'm going to go left 5, up 4. The negative needs to stay with the 5. And then I need to find, well, actually I don't need to find the hypotenuse. I've got opposite and I've got adjacent, and we don't have the hypotenuse. You never will have the hypotenuse on these problems. You've got to find it if you need it. But remember, tangent is opposite over adjacent. So if this is opposite and that's adjacent, then I'm good. 4 divided by negative 5. But we don't leave negatives in the denominator, so they can either float to the middle, negative 4/5, or they can just go to the numerator. Doesn't really matter. Okay? So either one of these is your answer. And then on number 60, we plot the point negative 3, negative 8. So think about going left and then down, which puts us in the third quadrant. So negative 3, negative 8. There's theta. Negative 3, negative 8. And I need to find sine of theta. So sine is opposite over hypotenuse, and I see that I have opposite and I have adjacent, but I do not have hypotenuse. So let's do Pythagorean theorem. A squared plus b squared equals c squared. A squared plus b squared equals c squared. That's a positive 9. That's a positive 64. And 64 plus 9 is 73. So that means c equals the square root of 73. I don't know why I put that as a 30. Okay, so sine is opposite over hypotenuse. So that means negative 8 over the square root of 73. And we want to rationalize, so we multiply top and bottom by the square root of 73. And this becomes negative 8 square root of 73 over just 73. 8 and 73 do not simplify, so we are done. Okay. On number 61, we're supposed to find secant of theta given the point 1, negative 7 is on the terminal side of the triangle. So a positive 1 means go to the right, and negative 7 means go down. So we're in the fourth quadrant. We're going to go right 1 and down 7. Your triangle does not have to be to scale, so don't worry about that necessarily. Negative 1 and 7. I need secant. Secant is reciprocal of cosine, and if cosine is adjacent over hypotenuse, and we have opposite, and we have adjacent, then we definitely need hypotenuse, okay? So Pythagorean theorem again. A squared plus b squared. A squared plus b squared equals c squared. 1 squared is 1. Negative 7 squared is a positive 49, which means we've got c squared equals 50, or c equals the square root of 50. If c equals the square root of 50, then again I gotta think what perfect square goes into it. And the largest one is, or the only one, 25 times 2. So the square root of 25 times 2 is 5 root 2. So we need to simplify, or we need to rewrite this. I don't know why I said rewrite. We just need to find the secant. Secant is hypotenuse over adjacent, so hypotenuse is 5 square roots of 2 over adjacent, which is 1. And divided by 1, you can leave it like that, or you can just rewrite it 5 square roots of 2. And there's your answer. Okay. On 62, you're supposed to convert from whatever it is to the other. If it's in radians, put it in degrees. If it's in degrees, put it in radians. Okay, so there's a couple ways to do this. One is to say, okay, I need to convert radians to degrees, which means I don't want pi, I want degrees, right? So you think about what you want to cancel out, and you want to cancel out pi, basically. Stuff out of the way. Okay, so if I'm going to cancel out pi, then I need pi to be in the denominator, so that it will actually cancel out. So when you think about the relationships that we have, the one conversion factor that we have is that pi is equal to 180 degrees. So we can say pi and 180 degrees, this is basically like dividing or multiplying by 1, because they're the same thing, just in different units. So when I do this, the pi's cancel out, and I can just simplify. So I'm going to multiply 16 times 180 divided by 9, and then do, oh, yeah, there you go, divides evenly. So it is just 320 degrees. Now, I'm going to pretend, like, say that was 16 times 180 divided by 5. Let's do, I want to divide evenly as well. This, let's go with 21. Okay, so then you get that, do math, enter, and get a fraction. Oh no, for degrees it should always be. I don't know what I'm doing. Okay, for degrees you should be good. It should just be whatever you get. If it's a decimal, then go ahead and put the decimal. I was thinking radians, never mind. Okay, the other option is, since 180 degrees and pi are the same thing, just replace that with 180 degrees. And you do the same thing, 16 times 180 divided by 9, and then you get 320 degrees. Okay, now if you're trying to convert 115 degrees into radians, then you would multiply. Now remember, it's always pi and 180. Just depends on which one goes on the bottom. I want to cancel out degrees, so I want to put 180 degrees in the denominator and then put pi on the top. So degrees will cancel out, and then here's what I suggest you do. This is what I was trying to think, the other one. 115 divided by 180. Okay, and you get this. You do math, enter, and then we get that fraction, and that's what you should definitely write it as. Notice how I didn't put pi in there and I didn't put the negative, 'cause, I mean, I could put the negative, it doesn't matter. I know it's a negative 23 pi over 36. What you want is the most simplified version without putting it in degree or in decimals, okay? So I would always divide those, rewrite it as a fraction, tack on the negative if there's one, and tack on pi. Okay? It says graph 2 periods of the following. So here's what I know. I know that the +3 on the outside determines the vertical shift, how much you go up and down, which will tell you your midline. So I go 1, 2, 3. And then it says it has a 3 in the front, and we have to remember that 3 in the numbers in the front of the sine or cosine multiplied, not added, subtracted, but multiplied, is the amplitude. So that's how high and how low you go. Red blue. So we go down 3 and up 3. And that is my amplitude lines, or those are my amplitude lines. And then we need to figure out the period of the wave. So the period of the wave is 2 pi divided by b, and b is the number in front of theta, or x in this case. So right there, x over 8 is the same thing as saying 1/8 x. So b is 1/8. And when you divide by 1/8, what we technically do is multiply by the reciprocal on top and bottom, 8 over 1. Or you can just remember that dividing by 1/8 is the same thing as multiplying by 8. Now, if you were to type that in your calculator, you'd get it just fine. 2 pi divided by parentheses 1 divided by 8, and you get 16. Well, I wouldn't tack on the pi because that would it would give you all the decimals, but if you typed in 2 divided by 1/8, I think it would give you the decimals. If you typed in 2 pi divided by 1/8, yeah, it gives you the decimal. So just type in 2 divided by 1/8, and it gives you 16, and just tack on pi. Okay, but the last part is actually laying it down on the graph. So here's what I know. I know that cosine waves start at the max, if it's a positive, and it is. Goes down, and then comes back up, and then there's the end of the wave, right? So I know that the period is 16 pi, so I'll lay down 16 pi at the end, right? So it does say graph 2 periods, which means 2 waves, and since it's centered, that means I'm going to have one on this side and one on the other side. And then it says label the x-coordinates of the main 5 points. So that means I need to label this, 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 and this. So I know that this starts at 0, this ends at 16 pi. Halfway between 0 and 16 pi has got to be 8 pi. And half of 8 pi has got to be 4 pi, so which means I'm counting by 4s. So 4 pi, 8 pi, which makes that 12 pi. And then these are just the opposite. Negative 4 pi, negative 8 pi, negative 12 pi, and negative 16 pi. And then we just lay it down. Starts at the top, ends at the top. Halfway through it should be at the minimum. Quarter of the way through it should be in midline, 3/4 midline. And remember, we've got to make sure that we are able to tell that they're curves, that you have the max and the min. Okay? And then the same thing on the side. Start here, end here. Or you can just keep the wave going. You can tell that you're doing this. So then just go here, 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 and there. Make sure that your points actually hit where they're supposed to. And make sure that your curve actually goes to those points. Okay? And there you go. One more. 4 cosine of 4 theta minus 1. So the minus 1 on the outside is my vertical shift, which tells me my midline. So down 1. The 4 in the front tells me my amplitude. So I've got my amplitude of 4. So 1, 2, 3, 4. Are you serious? I did 2 cosines. I'm gonna make that. I'm gonna make that a negative sign. Okay, so 1, 2, 3, 4. 1, 2, 3, 4. Okay. We've got to figure out the period of the wave. 2 pi divided by b. B is the number in front of theta, and in this case it's just 4. So that means that is pi over 2. Now I went ahead and started labeling. Remember, I want 2 periods of the wave, which means one on the right and one on the left. So the end of the wave should be the period, pi over 2. Okay? So then you need to label the others. And if you think about a negative sine wave, so sine starts in the middle, but negative goes down first and then comes up, right? This should be pi over 2. This should be half of that, and half of a half is a fourth, and then half of a fourth is an eighth. And really, when you cut something in half, basically it's like you're multiplying by 1/2. And if you multiply pi over 2 times 1/2, it equals pi over 4. And if you multiply pi over 4 times 1/2, you get pi over 8. Okay? Or just keep multiplying the denominator by 2. Now, I gotta figure out what that one is. So, think about this. This is 1/8 pi. So that we're going by 1/8. So 1/8, 2/8, and 2/8 simplifies down to 1/4, which makes that 3/8, and that 4/8. 4/8 is 1/2. So this is just 3 pi over 8. So I've got pi over 8, pi over 4, 3 pi over 8, and the same thing on the other side, only negative. So negative pi over 8, negative pi over 4, negative 3 pi over 8, and negative pi over 2. It is a negative sine wave, and we've already got it labeled out here. Starts at the midline at 0, ends at the midline. In the middle, it's at the midline. Fourth of the way, it's at the minimum, and then it's at the maximum. And then we just keep the wave going. So it does this, so it should go up, midline, down, midline. And there we go. And there's your graph. Okay. Your test will be very similar to these questions, so make sure that you know how to do these, because if you know how to do these, then you're good. But you gotta be able to look at them and know what to do. So definitely study. Okay.